What's up guys, Nitin here from A Second, and today, a special type of video. I'm back and new videos will be coming out every single week and we're going to start it off with a banger. So today, I was looking through the SAT. It's been a while I've taken the SAT. It's been about 4 or 5 years. I'm in college now, so there's no real point for me to take it. But I wanted to know what was the hardest SAT math problem that someone's seen or someone's taken. And so I found one on Quora, and on Quora we see that this person has found the coin paradox problem, and apparently it's the hardest SAT math problem in history ever. Why is that? Well, in May 1st of 1982, about 300,000 people took the test and only 3 people got it right. And so here's the question. So it says the following question is taken from the SAT General Aptitude Test that 300,000 Americans took in 1982. Only 3 students got the correct answer. Will you? So it's called round in circles. So we have a circle A and a circle B. The radius of circle A is 1/3 of the radius of circle B. Circle A rolls around circle B one trip back to its starting point. So basically what we see is that we have a circle. So we have the circle B and we have the circle A. And so A goes around B, it revolves around. And how many times, so circle A rolls around circle B one trip back to its starting point. How many times will circle A revolve in total? So we have 5 choices, and they say now for something to scrunch your mind in a different way. So I'll pause the video here if you want to take a second to solve this yourself. And if you have a guess, put it in the comments, and let's see if you get it right. So I'll take a second to pause it here. Alright, so now let's get into it, what the answer is. So this will be very shocking. So we scroll down and we see that the maker of the question got the question wrong. So the correct answer isn't even there. A majority of the people said 3 was the answer. And why is that? So let's see why. So it was even published in the newspaper at the time that there was an error found in the SAT question and only 3 people gave the correct answer. Well, what happened? Well, the scores had to be recalculated, and 300,000 students who took the test apparently were all baffled about what happened. Well, let's look at the question again, what they were saying. So the radius of circle A is 1/3 of the radius of circle B. So we know that this circle here, A, its radius, let's say its radius is 1, and for B, its radius is 3. So we see that the question is asking us that if A rolls around circle B and comes back to the starting point, how many times will circle A revolve in total? So the main question here is revolutions around circle B. And people chose 3, and many of you maybe chose 3 or didn't have an answer at all because the answer isn't even there. That's why it's called the coin paradox, because since the radius of circle A is 1/3 of the radius of circle B, a lot of people chose 3 as their answer. So they say, okay, so 1/3, and it's going to go around, so it'll probably take 3 times. But the question is not asking what the ratio between circle A, the radius of circle A and the radius of circle B, but rather the ratio between the center revolution radius of circle A to the radius of circle B. And in this question it's 4. And let's get into why it's 4. So generally speaking, it says the ratio of the radius of the green circle to the radius of the small circle A. That's what we're looking for in this question. And what that is basically, since the radius of the small circle, so let me draw this for you for our sake. So we have this circle B that has a radius of 3. And this is our circle B. So we'll label that B. And we have this circle A with the radius of 1. If I can draw a circle properly. So my circles are horrible. Alright, got it. That's fine. That'll do. So this one has a radius of 1. And notice how I'm drawing them. That they're in the same direction. And so this is circle A. Basically, since it's going to do a revolution, it's going to create another circle around circle B. Because that's what the revolution does. It creates another circle around it. And basically, the radius of the black circle, the outer one, which causes the revolution, as this circle A keeps on rotating or revolving around circle B, it will cause that black circle to form in our heads. And so what happens is that the black circle has a radius of 4. So that's our radius here. So if we put these two together, we'll get the radius of 4. And now we can put together the ratio. So we're putting the ratio of the green circle to the ratio of the radius of the red of circle A, the smaller one. 4 to 1, the answer is 4. And so in essence, you can see that the point at which the circle, it's a revolution rather than comparing the actual radiuses or the radii. And there's an example here shown as well. If the radius was a 2 to 1 ratio, here it's a 3 to 1 ratio. It causes another circle to form. If it's 2 to 1, you get this kidney shape. So this black circle here on the right has a radius of 1. The blue circle in the middle has a radius of 2. The black revolves around the blue and causes the red kidney-shaped line. But if both of the circles have equal radii, then you have this heart shape. So the red revolves around the black circle and it causes that heart shaped. And many people who made the SAT papers chose this math problem failed to see the essence of the coin paradox. And so this person who wrote this response to the original question, what is the hardest SAT question, has said this is the hardest math problem in the SAT history. Well, that's for you to decide if you think this is the hardest SAT question, or is it even a question at all? Because there was no answer to the question, which makes it that paradox. And so does it even qualify as a question to begin with? Because we couldn't even figure it out. This is not a fill-in question. It's a multiple choice question. And so I'm guessing that the graders had to go through every person's actual paper test and look at, I don't even know at that time if they had the technology to have a scanner as we do now. If we could just scan someone's Scantron and see if they got it right or wrong. Here they probably had a separate piece of paper which they graded, but they had to check if they had 4 since 3 people did. And that's a very interesting thing of, did the person who said that the answer's not there told the proctor or the test grader, or did they actually look through 300,000 and find those 3? Very interesting. I'm very curious to see what you think. I will link this question and answer down below. Let me know what you think. Hopefully you enjoyed. If you need any tutoring help, I charge $0.01 a second. Email me. Everything's in the description. Hopefully this helped. Thank you for watching.